Hello everyone, and welcome to our presentation. Today's presentation will showcase some functionality to help speed up your grading tasks and projects. Our presenter is Kevin Spear. Kevin joined Synergis back in 2012 and serves as an applications consultant, working with our AEC customers on software implementations, training, and custom consulting projects. He has more than 25 years experience and is also a professional engineer. Before I turn things over to Kevin, I just wanted to give a quick overview of who we are. Synergis has been a partner of Autodesk for more than 30 years. We sold our first copy of AutoCAD back in 1985, and since then we've been recognized as one of the Mid-Atlantic's most prestigious resellers, consultants, and service providers. We are also an Autodesk authorized training center, offering training on all Autodesk products in person at our training center or with our innovative distance learning solution, Synergis Educast. Our primary focus is on making companies of all sizes more competitive, more innovative, and more successful by leveraging your investment in the Autodesk solution set with particular attention on innovative ways to utilize and manage your data. So with that being said, I'll go ahead and turn things over to Kevin for today's presentation. Thanks, Kevin.
Good morning, everyone. Hope everyone's having a great week. Today's agenda, we'll take a look at some objectives, some challenges, and some solutions that we're dealing with in the land development genre of design, I guess you could say. So for objectives, here's what I'm trying to accomplish today. We're going to introduce a new tool, the grading optimization tool, what its different toggles and switches and functions, what they are. We'll define a few things. We'll learn how to monitor the algorithm that's happening in the background and understand, whether to cut things short or to let it keep going. Are we getting the result we're after? And ultimately, how do we push this back into Civil 3D? Because this is an external tool to the application, so it's got its own install. You'll see. But anyway, once we get through that process, we review it, bring it in Civil 3D, check print, blah, 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 QC, all that normal process, and then revise. We just repeat the process. So why are we doing this? Why are we creating this tool to speed up grading solutions? So that leads me to our challenges. It's time consuming. It's a manual process for sure. Requires individual thought in each little interaction, whether it's a driveway access, parking lot, detention basin, things we've all done 100 times. But there's only so much that we can automate inside of Civil 3D with our current tool set, which is just feature lines and grading objects, ultimately building a surface. So when design requirements change, because they will, those revisions sometimes lead to starting over simply because the framework or how we set out initially doesn't really support those design changes. And ultimately what we're trying to do is save money for our client, right? So we've got this great design, but now we've got to bring in 10,000 trucks, and that's not really helpful, right? We're going to try to keep the dirt on site as much as possible and use everything we have to our disposal. So that leads us to questions. What if you could reduce the time it takes to get that grading solution? What if you could generate options? What if you could use that solution directly in Civil 3D? And ultimately, those solutions can be balanced as a byproduct of the iterations. So what if we could do all those things? So loosely speaking, the answer to those what ifs is something called generative design. The idea is we take some input, feed it to a computer, and the computer outputs options, different solutions. It's not an easy button, right? We still have to provide input. You just can't go, here's 5, 10, 12. There's got to be context. There's got to be understanding. All of those things are experience and or otherwise education that comes from an engineer. Just can't plug in numbers and expect an answer, right? Garbage in, garbage out. So that leads us to the tool itself, grading optimization. What is it? It's two primary pieces to the equation. One is constraints. These are our input guidelines. So If we have a parking lot, maybe we want to range the slope in the parking lot anywhere from 2% up to maybe 10%. Maybe the building elevation needs to be flat, and it can range from one elevation to another, or maybe we can, do some reveal around the building if that's possible. So all those different types of parameters we call constraints. Those constraints can be applied to individual points, like a low point or high point, lines. So that could be a curb line, that could be a drain line, anything of a linear nature. And then areas, so parking lots is an example of that, a detention basin. So lots of different, pieces that make up that puzzle that we can apply constraints to. Now, with all those constraints, something, how do we govern what wins, what loses, what takes precedence, that sort of thing. So those are our objectives. Our objectives boil down to three primary objectives. Are we going to balance, cut, and fill? Do we want to minimize earthwork? And how smooth do we want the surface? Those objectives can be applied globally as well as individually to each constraint that we are driving. So maybe the parking lot, we want to balance, cut, and fill, but we're not so worried about smooth or minimize earthwork. If we're doing a path through a parkway, maybe I don't care about the balance of the cut and fill, but I want it smooth because I got to walk on it, or right. So we've got to pick and choose what our objective is for that given scenario. So what does that look like when we use it? So here's a quick snapshot. Here's a site I created, basic building with a parking lot that drains to a basin. I've got some drainage that goes around the building, of course. So we have some offsite drainage. And as you can see there in the right-hand photo is our convergence plots. There's three of them for each one of those objectives. One for feasibility, how plausible is it to create that solution given that iteration. Our volumes. So you can see in that particular picture in the lower left, while I do have a lot of cut and a lot of fill, it's balanced roughly. And then smoothness. So I'm not super smooth, but I'm pretty good, all things considered. And again, that's overall surface. So I may have some pieces that don't need to be smooth and other parts that do. Now, the oscillation and the feasibility, that's as the algorithm is adjusting different features. So of course, that's going to go up and down over time. Now, in my case, this approaches 0 or 1, right? So that's making it feasible. In other instances, we'll see this oscillate and it won't approach 1, it'll approach some higher number. And in those cases, we've got to adjust some of our input parameters in order to make things more feasible. And then ultimately, we're going to push this back into Civil 3D. That's the easy part. All right, so let's get into it. So here I have Civil 3D. I've got a surface. I've got a background image just to kind of show where I am. So I've got this field. It's kind of undeveloped. It's used for agriculture right now. So why not put an office building there? That's what we do, right? A main road here. Lots of stuff going on in the neighborhood. Good spot for an office building, right? If I lived over here, that'd be a great place to have an office, right? I could just walk to it. So simple layout here, probably more parking than I need for a building, right? That's pretty common in standards. But all I have here to start, I've just got some hatches. I've got a poly line that's closed. Right, I've got some blocks here showing the parking. Just your basic 2D layout, nothing super fancy there. Right, I've got my ADA spaces there in front of the building. Your basic site plan, right? The only thing that's probably slightly different than normal is I've got a couple of lines here that represent, I'll call them gutter lines. Basically the swales in the parking lot. I'm going to end up with a basin down here. This is the low part of my site. And I've also got a couple of closed polylines that represent the limit of where I want to grade. I don't want to grade the entire site. Got some nice trees in here. I might even decide to pull this in if I can make the basin smaller based on whatever my needs are for volume. Right, there's some nice looking trees over there. So I'll start here. to do the process. Now, first I should mention that where is the tool located in the interface. So in the ribbon on the Analyze tab, we have a grading optimization panel. That panel is not there by default when you install Civil 3D. It's actually an add-on. I wouldn't even call it an add-on. It's an add-on in the sense of HydroFlow hydrographs is an add-on, or storm sewers, right? Those are external programs we just happen to launch from inside of Civil 3D. And these are just simply the buttons to do that process. So where do we find it? You can find it in your desktop app, right? So I've already got mine installed. So I come here to my products, my products. I scroll down, and one of these will say grading optimization, if I can find it in 2 seconds or less. There it is. Oh, look at that. There's a brand new update. I'll talk about that. Obviously, I don't have time to update it right now. So that's where it will show up. If it doesn't show up, there are 2 things that could be the culprit. One, you don't have the AEC collection, right? It's only included with the license of the collection. If you just have Civil 3D, it's not included. The other thing is it has to be entitled like everything else. So your contractor or software manager has to go into their Autodesk platform portal and give you access to the software. And then I'll make it also show up here. Right, so you click I agree and install, and off you go. All right, so enough of how you get it. Once you've done that, this panel will then show up in the Analyze tab. So the first thing I'm going to do is click this Grading Objects button. What does that do? It opened up a couple of things actually all at once. One is a object browser. So this is very similar to our tool space here in Civil 3D, but because these things generally are living outside of the Civil 3D framework, we have our own browser for those objects. So as I create things, zones or drain lines, whatever it is, right, they'll show up under these different categories. So I'm going to minimize this tool space for 2 seconds. The other thing that pops up is our tool palette. Now this tool palette is the standard tool palette, right? I've got all my Civil 3D tools, and I just happen to be looking at the Civil Grading tool palette group, which I'm pretty sure I created that myself actually to put all these parking and landscape things in. But if you go to all palettes, then it'll also show up there too. So what's in here? These are specific tools. Now, what are we talking about? So for instance, I've got this building polyline, right? So I've got a tool here to create a building pad, right? So I pick the tool. It says select the object set as the building pad. So I'll pick my polyline there. And then press enter. And then I get this properties. And you can see why it's helpful to have multiple screens here, right? And we'll call this building one, whatever, it's a campus, right? You can have multiple buildings. I can either give it specific elevation at a fixed value or a range, or I can just say make it level. And as far as earthwork code goes, we're on a slab and it's 18 inches thick. And then I've got a color for it. You'll see what that means here in a moment. So there's my properties, and when I hit escape, it goes away, sort of like Quick Properties does in just vanilla AutoCAD. If I select the line, that polyline, right, it still knows that even though AutoCAD thinks it's a polyline, the grading tool set now knows it as a building pad. And so you would go through that whole process defining all your things. Now, creating these 2D objects, right, that's same as always, right? So here's my parking lot. So I'll come here to parking lot, pick my closed polyline, and then press enter to finish the selection. And then there's my properties. Now this has got a few more toggles. That's interesting. Let me try that one more time. there it goes. So we'll just call this parking. Naming conventions are always appropriate. This is a simple site, so it's not super difficult to name things. As far as the properties that go here, we have options here. And then depending on the option, there's an I. So if you don't know what something means, you simply click the I and it'll tell you. So in this case, I might want to use the custom slope constraint option. So that allows me to manually change restrictions, constraints for a given zone. So in this case, my parking, maybe I'm okay with, maybe 8% down to 2%. I don't want anything too flat. I've got some other options here for orientation and processing information. So I've got exclusive drainage checked here, for instance. So that means the zone considers only drain elements that are inside the zone. Anything outside, it ignores. So drain lines, for instance, if they're, I'm only looking to shape this zone based on drain lines inside that area. If I turn that off, then a drain line on the outside of this parking lot, maybe there's a swale adjacent to it, can also impact the elevation of that. Right. So if I want this to slope towards that drain as well as the side slope, then I would turn off exclusive drainage. I could still have a swale there. It's just this road or this access drive won't be impacted by it. So that's what exclusive drainage means. And there's some other options here. Break line, that's pretty straightforward. Grading limit, I'll define that here in a moment. But here are our objectives. By default, they're all three turned on. But maybe for this, I don't care about earthwork, right? It's such a big flat area, generally speaking. I'm not necessarily, I don't care if I've got to truck dirt from one side of the site to the other to do it. But let's just go ahead and give it some options there. Anyway, so different aspects to each piece. The last thing I'll do is I'll use one of my outside lines to create what's called a grading limit. A grading limit is essentially our connection point to the existing grade. So I'll just call it limit. And I could use global constraints here for that. That's fine. And I don't care about aligning the surface or anything else, right? There's no depth of material. But I do want to check on this grading limit. Now let me kind of move this over for 2 seconds. And let's dock it. That will be better. Here, let's do that for 2 seconds. Notice, of course, my building and my parking overlap the area of my grading limit. So how does it choose what to do? So if I told this grading limit to be a certain slope restriction, I think I said 0.5% to up to 3 to 1, versus my parking lot, which I generally want 2% to 8%, right, a little flatter. What wins, and how does that get taken into consideration in these objectives, right? Because if I say minimize earthwork for the whole thing, but I don't for the parking lot, how does it decide who wins? We'll get to that in a moment, but that is important. Let me look at the rest of my properties here. Those are good for right now. And if I look now in my objects browser, I'll see my grading limit, I'll see my zone, and I'll see my building pad. And I can pick on them here in the browser, and that also brings up the properties. So very, very similar to what we would do in Toolspace, but it's its own browser. So I've got 3 things in there, nothing super fancy. I didn't even put in the curved islands just yet. We'll just leave them as edge of pavement kind of thing. So once we've got whatever constraints that they want to apply, our last button here is to optimize. So it's going to launch a grading optimization viewer. So now it's loading in the terrain and my tools that I established. Notice we have the same browser here for objects. And if I pick on something here, I get the same properties. I can change the properties here or back in Civil 3D, it doesn't matter. It's all the same data. Right, same thing for my zone. Right, there's my zone properties. There's a couple of additional tools here. As I hover over something, you'll see I get both a toggle and an eyeball. So the toggle means process or not process. And the eyeball is simply just don't show it. So there's choices there for visibility and whether they're processed or not. If I had additional zones, I can actually drag them up and down to kind of reorder them. It's what we always wished could happen for point groups, right? If I need to order point groups in Civil 3D, I've got to go into the properties and then manually push up and down. Here, all I got to do is drag and drop. So as I get this, the evolution of this site, we'll see more zones, and then I can order them as I see fit. Now, what's the importance of the order? Anyone that's done a composite surface in Civil 3D is distinctly aware of that the order is important. Normally, we would start with a larger surface, and then all of our pieces stack on top of that. And ultimately, it sort of feels like a wedding cake. This is no different in the order of zones. So in the case of my grading limit and my parking lot, I want the parking to win. Now, the grading limit, when something is defined as a grading limit, that's automatically pushed to the bottom of the priority. It's the last thing considered. So in some cases, people will do a double, an offset, if you will, inside of that grading limit to kind of, let's say, better manage what happens between our design things and that grading edge. Otherwise, it's going to try to straight grade and could do some weird things. We'll see. But otherwise, there's a reason to create an offset of sorts from that grading limit. All right, so enough talking about what's happening. We've got some buttons down here in the bottom. I've got a reset button. So after each iteration, if I need to reset and kind of start again, that's where I would resume those iterations. The optimize button, I would actually start the calculations. But I've got this options button I'm going to start in first. So when we say global constraints for a given object, those global constraints come from these options that we can define here. So here's 33 and then 0.05%, right? So that's, if I chose global, that's what shows up here for min and max. So that's where we've set those. Iteration, right? You can set this as high as, I think, 100 million. That's really long. For the sake of demonstration, I'm going to just do 10,000. We could even do 1,000 to make it really short. And then you can, define what's important to you of those objectives. You can set all of these down to 0 and, maybe bump one up and kind of prioritize one thing over the other. And that'll simplify some of the processing. But normally you might have these maybe somewhere like that. Maybe this is up at 100. Maybe this is at 50. Maybe that's at 100, right? So you can prioritize each one of these objectives. And if we're balancing, what is our target? So the default is net 0. But if this site's got good dirt and you've got another project somewhere else and you want to get rid of some dirt here, take some dirt off site, right? So net cut, if you will. So then that would be a positive number. So if I want more cut than fill, that would be, maybe I need 10,000 yards of 10,000 cubic feet of dirt. That would be a positive 10,000. If I needed to truck in dirt, I've got dirt from another site, then that would be a negative number. So that's all there is to it. And there's a little equation here to kind of help you remember that. I think Civil 3D grading objects is actually the inverse. It's fill minus cut. So if you want excess cut, it would be a negative number. Anyway, so how do we balance, right? We got a choice there. I'm going to set that back to 0, close this. And let's just go ahead and hit the optimize button. We get some feedback here. What's happening? If I look down in this corner, here's those convergence plots that I was discussing, and it's on my other screen. Let me bring it across. So as things are progressing, you can see Pretty feasible, but probably not a great solution given the number of iterations that I told it to do. And we can see some of these different plots. And as you hover over them, right, for a given iteration, I can see where it's approaching. So let's reset that. And let's bump the iteration up to 10,000 and see the difference. Now I've only got, what, 3 items for it to think about. I don't have a basin in there. I don't have curved islands. No drainage really of anything to really tell it what to do. So it's a very feasible solution, right? There's not a lot of complications to the scenario, but we'll change that, right? All right, so we're already pretty much, you know, at 0 at this point, so that's pretty feasible. So I'll just hit stop. And ultimately, what we might want to do is send this result. Oops, send that result right there. But before I do that, let me cover a few other things over here in the lower left corner. There's a visualization toolbar so that as this iteration is happening, you can define different themes. So currently I'm just doing an elevation theme, but maybe I want to see where all the cut and fill is. So basically I'm in a little extra cut at the moment. Right, so most of it's green, the buildings in cut. I can also look at slope violations, and we're either looking at drainage or max or both. So not too many violations. In the building, we don't care because that's going to be flat, right? That's going to happen. So we have that ability. The other thing that we can do is I'm currently showing contours, but I could show the mesh that's defining the surface. And I can also show direction vectors. Maybe. But since I don't have, I need something that defines drainage in the grading tool. That is defined by either a low point or a drain line. Those are our 2 primary tools for doing that. Neither of which I have, right? So it doesn't really know what it's trying to do for drainage. The other thing I can do is I can set the interval for, in this case, elevations. So if I wanted half-foot contours, right, I could set that up. That's pretty easy. You know, 2-foot contours, whatever, right? Really easy to do that. And you can set your ranges for slope. So if I switch to the slope view, maybe I just want 2. And then I can define what those ranges are. And nothing super different there than what we would do with the surface in Civil 3D, but it's inside this visualization tool. All right. So some of our visualization options. We also have preferences. So when we're defining our model, do we want to refine the surface? Well, that's kind of our goal. But if we don't, we can improve feasibility. Mesh quality. So in a conceptual stage, I would set this to low. But if I was trying to do like a final design, maybe medium was preliminary and high was final. But in this conceptual stage, low is fine. Remove EG points and customize max triangle size. I kind of leave those off because inside the grading limit, it's doing its own thing and we don't have that much of an issue necessarily. So we have options, but I haven't seen a need to use them. So that's the interface in a nutshell. Ultimately, if this was our solution, we would hit send result. And we get 3 things that we can send into Civil 3D. The surface that it built, which could be defined as a new surface in Civil 3D, give it a name and a style, or we could say update an existing surface. We can send feature lines, put them in a site, give them a style. And we can also send points. Now, no points are created because I have no drainage points, right? There's no directional aspect, if you will, to the surface, so it didn't create anything. But you don't have to send something. So you pick a surface, give a surface name, hit finish, and then ultimately that data would be in. So we'll say concept grading complete with my spelling error. There we go. And we'll pick our style. We'll say 1 of 5 design, and then I'll finish. Now, when it brings in the surface, there are a couple of things. It's everything. So let's go back to our tool space and look at our surfaces. There's my concept grading. And actually, for 2 seconds, let me just do the border. Right, so it's literally the whole site. It's the, it included both my EG and my proposed surface. So one of the things we typically have to do when we bring in a surface like that is add a boundary. Now, that grading limit can also be used as a boundary. So I'll simply add that. We'll say outer, and this will be outer, and I'll make it, we'll make it non-destructive, why not? And we're looking for, I think I used that one. Now my surface is there. And let's set the style to 1 of 5 design. And there's my design. Now, okay, so now I've got to add some curb, right? So here, let's just kind of further refine this a little bit. So we'll say this is a curb. Now, a curb can either be a closed polyline, or maybe this was all a line, right? Just the outer edge. I could do that as a curb, but I'm just going to do that piece, these 4 islands. Right, select Autodesk curve 4, we're good. Hit enter. Now I've got them selected. It didn't prompt me for settings, but if I look at my objects browser, there's 4 curves. If I look at my properties, it shows me the properties for all of them at once. So we'll set them all to 1/2 foot wide and 1/2 foot tall. Now this is your standard curve. It's not laid back or anything like that. We're just, again, we're just trying to do basic grading design here. And also this is version 1. Ultimately, we'll have multiple shapes here soon. All right, so there's my curve. I got some new information. Let's go back to the optimize. Select EG surface. Yep, I just EG as my background again. Now, the reason it prompted me there is I now have 2 surfaces in my Civil 3D file. Before I only had 1, so it was obvious. So now I've got my 4 curves. Right, let's go ahead and click optimize. Right, that's going to add a little more depth. And if we look at our plots, right, again, similar output, except we'll have curved islands there. Well, let's just run for another few seconds or so. Man, that's going to 0 in a hurry. So a few things to impact. All right, so I'm just going to hit stop there. And there's my, we'll just assume that's a solution. Right, so I've made a revision. So for my surface, I'm not going to bring in my feature lines, but I do want to update an existing surface, concept grading, that's fine. We'll hit finish. And now that surface is now reflects those new changes. I thought I set the style. Oh, you know what? Here, let's freeze my image. It's a little tough to see. There we go. So there is my surface right there. Kind of following the existing ground outside of my parking lot. I'd like to actually kind of grade that a little better, of course. So that's where this additional polyline can come into play. My drain lines. So let me add a drain line. One thing to note about a drain line, when we create them, we have to draw them downstream, so high point to low point. So I've got a couple here. I'll draw one in a second. So that would be drain line. I simply pick the object. It already knows the direction. I look at the properties. There's nothing but a name. That's pretty straightforward, and a color. So we'll do the same thing for the other side. Offset drain line. Pick the drain line. There we go. Now it's a drain line. All right, so how do I create a drain line? Polyline, line. And let's say I wanted to make sure this area got to my basin down here. So I'm simply gonna, turn off my ortho. And let's turn off the OSNAP too. So generally, you know, how I want to get water to the basin, wherever that basin might be. You know, something like that, right? Now when I create a drain line, I simply pick that polyline, and because I started at the north end and drew south, right, that's the direction of flow, I now have a drain line in that direction. That's as hard as it is. So this is all 2D stuff that we're starting with. Same thing, let's do the ADA stuff, right? So I just got a simple polyline around that. So in that case, I would do accessible path. I can pick that polyline, and now I've got properties for that zone. So I might call this ADA parking, right? What's my max and min slope? Maybe I could go 0.5 if I was, you know, willing to do that. Break lines, you know, do I care about bounce, cut, and fill? Not really. Do I care about moving dirt or not? Not really. But I do care about it being smooth. Okay, fine, fair enough. That's our ADA parking. So that's the process for all the different bits and pieces, whether it's a building pad, a reveal, a pond, right? They're all pretty much that same idea. Now, the one thing that needs something else besides a polyline is a low point grading object. This requires a Kogo point. So let's fake in a basin for 2 seconds. So maybe something like this. We'll say a flat edge for most of it. Throw in an arc. Now let's be a little landscapey. And then we'll close it. Perfect. Exactly what I was thinking for basin, right? So how do we create Kogo points? Manual. And I'm just going to pick a point in the basin, and we'll call this little point. Doesn't need an elevation, so that's fine. There it is. Pretty straightforward Kogo point. Now when I get to my grading object, low point, select objects as low point. So I pick my Kogo point. And look at my properties. Again, it's just a name, and off we go. That's my piece. So let's take a look and see what happens now. So we'll go back to Analyze, Optimize. Again, I need to know what's my parent base surface, EG. That's fine. And we'll hit Optimize. So I've got a little bit more for it to think about. Let's take a look at our convergence. Again, not too bad because we don't have a whole lot driving stuff. That looks pretty good. But it is flattening out above 1. Oh, there we go. Got a nice little dip again. So it may take a few moments for it to figure out a solution. Now, ultimately, if it does flatten out, we just need to change our constraints. Okay, so I'm just going to stop it there. And of course, ultimately, if we would update our surface. Now, let me move forward in time a little bit. I've added a few more bits to the puzzle. So I've added a pond. Right, so I've got pond properties. So I can define my volume, my depth, basic aspects of a pond. I've got a couple of more drainage lines here. I did add a sidewalk along the front here. And I did add another accessible path up to the building. I probably could have made it all one, but I wanted to kind of separate it from the parking lot. The other thing too here is I want these to touch or even overlap so that there is some thought of continuity. So one thing I often like to do in this situation is use my object snap tracking. And so I'll just sit on that point. I wanted to move endpoint. There we go. Now I'm doing an extension of that line. Let's just say it was 0.5 feet into the building. There, so I've got a half a foot overlap. I think I'm good. So let's try that. I also added, I think I added that as an internal. Oops. Yes, I did. So I've got two there. So let's go to the optimize tool. And let's take a look at some of the ordering now that I've got a bunch of things in here. So a few more things here to calculate, if you will. So I've got 5 zones. I pushed, so this grading limits is this internal line, right? So I put that at the bottom, then my parking and then the front walk. Things that are adjacent aren't necessarily critical as to sequence, but things that do overlap, we do. Have a preference. What else? So there's my grading limit, set to outer. Notice everything is turned on and visible. There's my for curb. There's my pond and my pad, my drain lines and my low point. So let's take a look, see what happens. We'll go ahead and optimize. And let's take a look at our convergence plots. Now, while this is doing it, how do we navigate? Because you might want to look at this from a different angle. So right now, just clicking and dragging, and that's sort of an orbit, if you will. If I scroll the wheel, of course, that's zoom. Those are our two main things. If I hold the wheel, I can zoom in and out as well. So that's the same thing as scroll. If I hold shift and left click, that's pan. So our basic tool set, it's very similar to InfraWorks for those that have used that. Now you can see I've got a bit of a little bit of noise there up front. So as it starts to vacillate on some different constraints, it's starting to figure things out here, and the feasibility curve starts to get, shall we say, a little smoother. And of course, it'll go up and down. And it's taking a little longer because there's more things to think about. And I think I put the iterations up at 10, yeah, 10,000. There we go. So currently I'm at excess cut, which is fine. No, excess fill. Right, so cut minus fill gives me a negative net value. There we go. All right, so a little cleaner there on my convergence. What else can I do? So now that we're looking at this thing in motion, what if I go to the violations? So for each tin face, it's calculating or responding to those constraints. Does this face meet those constraints or not? Right, so we've got different constraints, maximum or minimum. Now, in some areas we may care, some areas we may not. There's a slider here to exaggerate what's happening. So if you're in a flat area, right, we can kind of see things a little easier. When no exaggeration, it's kind of tough to see what's going on in this site. But here we can kind of see how things are shaping up. And again, this is early in the process, right? There's my pretty little curved islands. What else can we do here? So let's take a look at our wireframe, right? That's what we were just showing with the violations. What about our hydrology? So now we get to see some of our directional flow, if you will. It's kind of cool sometimes to kind of take a look at a side view to kind of watch things iterate. So one of the things that happens in the convergence plot is as, let's see if I can find a spot to show all this at the same time. There we go. Right, as this oscillates, it becomes less feasible. You may see certain areas go up and certain areas go down and vice versa, right, when we get to the bottom of this. Now, ultimately, this will, because I've run this a few times, it does become feasible. It just takes a little while. So in lieu of that, let me check my PowerPoint here and see where we're at. So that's where we left off our demo, right? So let's review some of the quick tips while I was processing. Constraints and objectives are two pieces to the puzzle. Constraints win over objectives. We're always trying to meet constraints, sometimes in spite of objectives. So the solver is trying to pick one, so we have to, which one wins, so constraints will always win. Objectives, if we set them to 0, as I mentioned before, basically it just becomes a feasibility study, right? We're not worried about cut and fill or anything else. And ultimately, proximity in that graph, that feasibility graph, means that's a feasible solution. If it doesn't approach 0, if it stays at a higher number, then that's probably an unfeasible solution. You saw that I didn't get great results without drain elements, right? So putting drain lines in or low points are going to help us out. Our grading limit is our daylight line, our connection to the EG. The first time I played with this, I tried to do an existing site I'd already done, which was not a bad place to start. But the problem was I had put in super tight limitations. I tried to give it the actual thing, and I hadn't really constructed all the different polylines and lines and points in a certain fashion that it just couldn't find a feasible solution, even though it was an existing design. So basically what I'm saying is when you're starting, relax some of the constraints so we can give the algorithm somewhere to go. And then ultimately, as you iterate, I think I did, I don't know, 10 iterations in the span of like a half an hour yesterday, playing around with some options. So it's not like it takes a great deal of time. And then the last is when we have zones that overlap, it kind of feels and functions like a composite surface. So we want to order those important zones above ones that are less important so that those slope constraints would then win. All right, so let me jump over to our questions. I see a few questions here. So the first question I see, it says, where is the optimizer getting surface data from? That's a good question. So let me jump back into this. So you can see that that's oscillating. Can I switch to Civil 3D? Nope, I cannot. It's holding it hot. Oh, wait, no, it's not holding hostage. So in my site plan final, I have one surface at the moment, just an EG. So this, I didn't actually bring the data back in. So if there's only one surface, that's the surface it's using to start the context for all the different pieces. Once, if I switch to my my starting point, and in that case I brought in that concept, right? The next time I went into the optimizer, it's like, which one's my base surface? And then that's when I had to tell it use the EG. It says, can you define the multiple surfaces? So the optimizer is looking for an FG only. Some of the depths and different things that we're giving it in the parameters of the constraints is to simply help the objectives, whether it's cut fill or moving earth or I forget what the other one was, feasibility, right? Is it possible? Smoothness, right? So we're looking at those objectives. So I can't really get a datum surface out of the parking lot if that's what you're asking. However, when I do send the results, I can send the feature lines, and then I can build a datum surface out of those feature lines and do it that way. But the optimizer itself only builds the final grade. So those two questions were from Brian. Oh, and this third one is also from Brian. His question is, do we need advanced hardware to complete these iterations, or will the typical CAD workstation manage this? So that's a great question. My computer at the moment is 5 years old. It is a Dell Precision laptop. It's kind of middle of the road then. And I would say it's pretty standard spec for Civil 3D. So I've got 32 gigs of RAM. I've got an SSD hard drive. And I've got a secondary hard drive, but it's just for data. Actually, this data is that's a different process, I guess. It's working off my hard drive, my internal hard drive, internal SSD drive. So that could be impacting. But the process, that's actually a good question here. Let's take a look at our task manager, right? What the heck is happening in our performance? So the CPU is going to go crazy there, right? That's expected. But nothing that it can't handle. Memory, that's pretty standard too. It's not really peaking out. That seems fine. It's not, doesn't seem to be hitting either hard drive. So from a hardware perspective, your basic CAD machine is going to work fine, it looks like. That's a great question. Any other questions out there in the audience? Let's see. All right. Not seeing any other questions. Let's take a look at our. Yeah, we've definitely oscillated. So I could stop it, right? It's close enough. Take a look at this. Now that's exaggerated really badly, right? Let's flatten it back out. And then there's our solution, right? So I've got a little swale over on the side. Again, it's using the exclusion drainage, right? So it's using this drain line, not this one, to slope my pavement surface. And I got a nice little 3-to-1 slope there coming down to my drain line. Same thing over there. Looks pretty good. How can we check slopes? Actually, we can go to the violations and hover over a given face, and it's going to tell me what's happening. So we're roughly 10%. So that's 10 to 1, right? So not too steep in there. Where are we at in front of the basin? 5%. That's not too bad. Looks pretty good. So I'm going to go ahead and bring this back to Civil 3D. And so there's my drain point, and I'll bring it all in. That's fine. We'll say final. Oops. How long have I been typing? Way too long. Yeah, it's always a challenge. All right, so there's my surface. Feature lines, I'll put them in FG control, I'll call it. Basic, that's fine. And a point, we'll say FG drainage for a point group, and that's fine for style. Okay, perfect. All right, so we'll do one more thing there. We'll go into that final and then add a boundary, just like I did before, called outer, non-destructive, pick my line. There we go. So there's my contours, there's my surface. Let's take a look at this in the viewer. Right, not too bad. Looks pretty good. It's got a few rough spots. Right, I might want to tweak some of that, but all things considered, that's not too bad for 20 minutes worth of time yesterday afternoon. It took me longer to actually lay out the 2D stuff than to do the grading optimization, ironically. And of course, at that point, you could do your volumes. Off you go, do all your normal Civil 3D stuff. Now, if you don't like, some of the things, how it worked, all these green lines, of course, are the feature lines that we brought in. So maybe you like the parking, but maybe you don't like, this berm ledge, whatever, right? Simply build a surface without it, and off you go. But you get all those tools. Like if you don't like how this put a high point on that feature line, right? Maybe we pick and choose how to change that, right? So now we have the actual tools. We can get really finite with it. Any last questions here? So if you do need help, of course, we are here for you, whether it's on a day-to-day basis or a project or getting started with new tools like grading optimization, we're here for you.